All right. So has everybody been able to start the homework? Communicating with the TA is going well?
Oh, yeah.
The syllabus, yes.
Yeah.
You have a TA, it's in the syllabus, yes. And all questions about homework or Zybooks goes to your TA. All right, today we're going to finish chapter 2 and get into chapter 1, get into chapter 2. We're going to go through it very quickly because it's just about Python, and we've been covering a lot of Python as we go. And who knows, maybe we'll get to chapter 3. Let's start out in your notebooks. So open up your collabs. Anyone know what that's about?
It's weird.
That's just how he is?
Yeah. It's how he teaches his business class. He makes a joke about it.
Well, maybe it works. All right. Does anyone have any questions about what we covered before in the notebook? All right. Now I want you to import something called scatterplot from Seaborn. You can just copy it exactly and tell me if you get any errors when you run it. And now that data frame, DF, is the one that we had before. And if I were you, I would keep this same notebook active. Now, you'll have to go back and rerun that cell, the one that loads the data frame. Otherwise, it won't know what DF even is.
That text in the English references that could be typed here to that one.
Okay, that is generated when I ran it.
Yes.
Yes, it's right there. From Seaborn, import scatterplot. Before that, you don't have to, but tell me what error you get. Syntax error. What error did you get?
I'm getting main error, main DF as well.
Yeah, so the DF was defined in a previous cell. I don't know why you would get a from Seaborn import. No.
Oh, that's okay.
That is.
Oh my God.
Okay, so that one works fine now. So I don't know, you had, I think, something for scatter, okay, and instead of scatter, put scatter plot.
Oh, this is the. I just have to go back and run it.
Yeah, okay. Remember the cell, remember the DM?
Are you still the same thing? Yeah, you gotta eat.
Are you
polars?
Keep everything active.
So.
So for
Yeah.
those of you who have to start over again, you'll have to rerun this cell. You don't need the polars part, but you need to have DF be something it knows about. Every time you step away from the notebook for a certain number of hours or minutes, it forgets you. All right. It also forgot that I had polars even. I have, if I need to use polars, which I don't care about right now, I could go back and do a pip install again. But I'm just going to ignore it for now with a pound sign. And then when I run this again, let's see. Yeah, PL is not, oh, okay, so I guess I am using PL to read the data frame, which means I do need to install the polars package again. So get my mouse out of the way. For those of you who have to do that, you run that cell to install polars. Then this cell will let the system know what DF even means. DF is the data frame that gets loaded from that file. At least the file is still there because it comes with Colab. Then I'm going to skip down here to run the scatter plot. Who wants me to go back up a little? No, we do that. Oh, it's not CPS. CPSC.
I love
Yeah. Okay, go up. Run that. Now it knows the DF.
Oh, those ratings.
See, now it knows, it didn't know what polars was. Now it's going to know what polars is. It's going to forget this next time. Now it's going to import polars. And now use polars, PL, see that? Yeah. To read the CSV. Now it knows what PL is.
So just like, well, we are using Python, every
Yeah, but only if you need it.
This Linux.
This time you need it because you didn't know what
you can't Linux terminal.
But there may be times when you need it. Yeah. But good job, it runs and it looks good. Okay. If you did not get that nice blue diagram that looks like that with the dots, raise your hand. All right, everyone got it. Good. Now, who can describe to me what a scatter plot is? It's just what it looks like. But what is it? Put it into words.
Point for every data value in a data set.
Yep. And the two things we're plotting are median income and median house value. We would expect some kind of relationship there, right? People who have more income might buy houses that are more valuable. And if it were an exact relationship, what shape would we see? Linear line, right? You would see a direct line if those two things were very related. But as we see, they're only mildly related. I mean, there are some people like this guy right here, he has one of the highest incomes, or maybe it's a region that has one of the highest incomes, and the house values are only here, whereas a linear relationship would have put it way up there. Now, also along the top, there's a bunch of dots just collecting along the top, like balloons that hit a ceiling. What's going on there? You reach the cap on something. Maybe it's the graph, maybe the actual data like that. Not the reality, but the data when they gathered it. Maybe they made a mistake and they only had some maximum. Data can be messy and it's ugly sometimes, and it's straight up wrong other times. Oftentimes when you plot it, such as using scatter plot, you can see how wrong it is. Or you can see things that are probably errors. Because we all know that in reality, there's diversity. In reality, there's never a situation where a whole bunch of people have exactly the same house value. Or a whole bunch of regions. So we know just by looking that there's something missing or wrong, whatever. Looking at the data helps. Okay, now I want you to create a list of lists where each list has the same length. You can do exactly what I did or something similar. Can everybody see that in the back? All right, once you have that in there, I want you to just put that on the line and run it. Now, when you're using a notebook, it will often tell you the value of variables without having to explicitly print them. It just decides to print it implicitly for you, which is nice. And that's what's happening on the next line here. So x0 printed out to the line. What does the 0 represent here? What is it doing? The square brackets and the 0.
It's the index.
Of which of them?
Of the first one.
Yep. But why is it giving a whole list?
Because
Yep, because the element itself is a list. And I want you to convince yourself this is true by trying x1 and x2. All right. Now let's try x2, 1, just like that. Who can explain to me what this is doing?
It's going to the second element for list of this, and then going to the first element of that list.
Yes, or actually, it's going to the third element in the list of lists and going to the second element in that list. You're close, yes, and just remember, it always starts at 0. Now, and this is called slicing. And we've sliced on 2 dimensions now. Now, if we want to do a range, someone asked about a range a couple classes ago, I think. Here's an example of a range, 1 to 3. Try that out. That's a good question. So I want you to play with this a little bit and see what range you have to put in that second square brackets to get the entire list for that subset. So in this case, to get 11 through 15, what range do you have to put to get all 11 through 15? Yes. Yep, because, well, why 5? It seems strange because 5 would represent a 6th element, but there isn't one.
Because the end of the range stops.
Yeah, everything up to that one and not including. This is just a choice someone made, and you'll find out who made that choice in a few minutes. But it's just a random arbitrary choice. I don't know why, but it's consistent, and that's what's important.
Wouldn't it be reflective of for loops that existed prior to that?
Yes, but there are some languages that use for loops where you will do the last thing in the range. But in Python, you do everything until the last thing in the range. I guess you could think about it as when you get to this number, just stop immediately. Don't execute the loop again. That's another way to think about it. But these are little idiosyncrasies of Python that you will get used to. All right. Any questions? All right, let's go back to where we left off before. Did I mention the Netflix prize last time? What do you guys remember about it?
$1 million prize, you'd have to like increase the efficiency of Netflix algorithm.
Mm-hmm. By how much?
80?
Nope. 10%. They had to get 10% better. But better was defined by root mean square error. If you remember, we talked a little bit about linear models and how what people try to minimize is the sum of the squares of these numbers, right? This is kind of like that, mean squared error. But the root mean square error means you add up all of these errors, and these are the errors squared. Then you take the square root of that. That's the root mean squared error. So the root mean squared error was some number, 9 point something.
You're adding up the errors and dividing by the total number of measurements.
Yes, mean.
Oh, just
You take the mean of the, I'm sorry, yeah. Over I, then take, whatever N is. So, yeah. So let's say you have some number, it was like 9 something, 2, 3. They had to make the RMSE 10% smaller. Whoever could do that first got $1 million. What else did I say about it last time?
They could only make it better by like barely.
At first, right? That's yeah.
And they eventually throw out the defense issue.
Yes. Now, some of this is in the Zy books, so you may have read it there too. Why did they throw it out?
They found they're using the wrong metric to find the success of the algorithm.
Yes, that's right. So they're asking the wrong question from the beginning. But in the book, they also talk about how it wasn't as efficient as they had hoped. When they scaled it up, it didn't quite work as well as they had hoped. There's a lot of things that can go wrong with the model. But the biggest surprise to me was that they threw it out because they were asking the wrong question from the get-go. And it took 2 years to do the contest. So their needs actually changed during those 2 years. All right, this is one thing to consider. We all think AI could help us in a lot of ways, and you think maybe it'll make things more efficient, but we are burning a heck of a lot of electricity to train these different models. So think about an average car for in a lifetime of the fuel that it burns. It's, this many pounds of CO2. Well, training and transformers are a lot more, and they're only going to get worse because people have been enjoying the success. ChatGPT has many, many users now. Did anyone guess how long it took them to get to 1 million users? 2 days, I think, or 5 days. And how about to 100 million users? A little longer, 2 months, but it's still amazing. Stable Diffusion, who here has tried that out, or Midjourney, or Lensa? These are all using big transformers, and companies with big pockets and a lot of compute have been able to train these. And what we've seen is that size has its own quality, quantity has its own quality. What it means is that we take some simple idea, the idea of the transformer, and just scale it up big enough. Really interesting things start to happen, but it's burning a lot of carbon and it's using up a lot of electricity. And some of these models, I've heard numbers like it may cost $100 million in compute time to train these things. So it's not efficient. It's not the way humans learn, for sure. Did we see this slide last time? I don't think so, did we? No. Okay. This doesn't even cover ChatGPT. ChatGPT is so far off the screen, it wouldn't even show on this chart. This is only up to ChatGPT 2. And the number of parameters in the model is like the weights and the biases, for instance, in a neural network. Remember, neural networks and all of these models are really just loads of math problems. Typically lots of matrix multiplications and additions, and exactly what number you store in there, to multiply by or add by at different points in the model. That's what makes the model do what it does. And GPT-2 had 8.3 billion parameters. Now, maybe to store that's not too heavy, but to do all the math, it takes some compute. But the biggest part is the training. Sometimes the training is like 1 million times more expensive than using it. And ChatGPT was, first of all, inheritor of GPT-3. which was trained on 1.1 million years of English. And it still makes stupid mistakes, right? But then that wasn't good enough. Even not that it's good enough now, but it's better now because they have a very large team of humans working for OpenAI. And these humans look at output and they tell it which output was good, which is bad.
We're using our own training as well.
Not exactly, but you're providing situations that they can then use. And if you provide feedback to ChatGPT and keep it going, and actually, if they can determine that your feedback indicates a positive result, that they did something right, then you are trained. But a lot of the times it's more nuanced and complicated, and they have to have a human go look at it. What's interesting is when you ask it a question that no one's ever asked it before, and it's not ready. One of the funniest ones I saw out there was, Mike's mom has 3 children, name one of them, and it can't do it. And it's Mike, I mean, come on, any human would get it. But the first time it saw that, it couldn't get it. However, after a few people out there on the internet thought of asking it, the humans who work for OpenAI could see that and go, okay, we got to fix it. And they put it in some kind of function to make that work right. Does that make sense? Another crazy thing someone thought of is, please explain to me how and why a horse rides a cowboy. And ChatGPT went into this long paragraph about how horses ride cowboys to get from this town to another, and they do it all the time, and it's very normal, and explains the whole story. So once a human thought of that, then another human at OpenAI can go in and see this is wrong and fix it for the next time. But they're never going to think of the infinite number of ways to go wrong. And they're waiting for you to mess with it and figure this out. Make sense? All right. We're done with chapter 1 stuff. Now, chapter 2. This is a guy who made Python. A lot of the decisions made by him. He started in 1991, I guess, but I didn't hear about it until 2008. And I thought that I was getting in early. Now, 1991, I suppose none of you existed yet. But 2008, how old were you guys? 5? Yeah. Well, it's become a very mature language since then. Python was this language that some of us saw as not as rigorous. It has loosey-goosey things like, instead of opening each scope section with a curly brace, you just tab over. That felt unprofessional at the time, but I think we've gotten used to it. Python really took off, especially for machine learning, AI, but anything backend. I prefer to use Python to just about anything else. Do any of you have experience with other languages? Raise your hand. All right. Why do you guys think Python is so popular?
It's easy to read.
Easy to read.
Is there so much you can do with it?
Yes. Tons of things you can do with it, and you don't have to do it from scratch. There's modules you can import.
And we're just like C++ for right, so syntax dependent, like you can, different programmers can have different syntaxes that still work because of the curly brackets. With Python, it's more standardized, so different companies can do it.
That's a very good point. I hadn't thought of that one. And there's a critical mass effect, right? So the more people use it, the more people want to use it. And that makes them make more APIs and makes other people want to use it more. Anyway, I love it. everything that I wrote in the old days, maybe using C++ or Perl, I can do it in Python in less than half the time. And it's easier to maintain. So there are paradigms in programming that some people talk about, like C++ was able to add object-oriented programming to before, but C was. And then there's programming languages like Haskell that are known for being functional programs. There are tons of different ways of looking at the concept of computer science. That's what a paradigm is, a way of looking at it, a way of approaching it. Whereas like a function-based paradigm would be, I'm going to make everything into a function, and I'm going to have functions call functions that call functions that call functions. Or doing it object-based, you want to hide the complexity of anything you do inside that object. Like if you have a bird object that's flying or an airplane object that's flying, they're doing very different things. One of them is flapping its wings, one of them is burning fuel, but they're both doing the flying activity. All of these paradigms can be done in Python. That's another reason that a lot of people like it. However you like to think, however your brain thinks, you can do it in Python. My brain thinks more along the lines of an object-oriented program than anything else. We'll be doing a lot of Python in notebooks. And in Zybooks, I think it even might act like a notebook. Who's tried out writing code in the Zybook? Is it like, just like this, right? Yeah. So a lot of these things are very obvious, copy paste. A new code cell, usually that'll be at the bottom, but you can also move them around. But the kernel is the thing in the background that actually runs the Python. When you open up a shell, you open up the actual Python interpreter. The notebook is a layer between those two things. So if you have, if you have Windows, maybe it's a PowerShell. If you have Mac, it's terminal, or a Linux machine, it's just a shell. Typically, you get a prompt, and when you type the word Python or Python 3, you will get the Python prompt. And now you're in Python. And any command you do, it can't be a Linux command anymore, it has to be a Python command. And when you run it, you will get what you expect. In the Python command prompt, if you were to write a function, define a function, def, func, whatever, you would have to do the spacing manually each step for anything inside that function. Whether it's 2 spaces or 4 spaces, just be consistent. It's not the easiest way to program. So typically people work in a notebook, or they work in a file editor or an IDE. Who here has a favorite IDE? Name some.
VS Code.
How about you?
VS Code.
I don't use VS Code.
All right, who else likes VS Code the best? All right, who else likes something else the best?
Weirdo, I didn't know
Notepad++, all right.
Use Neovim.
Neovim. And is that just text-based?
Yeah.
All right, anybody else, anything else? This is my favorite. And it's another text-based one. And I just love it. I have all of the muscle memory of all the shortcuts. in my fingers. And when you get used to an IDE, it becomes easier and easier over time, I find. Anyway, this interpreter is being run behind the scenes every time you're in a cell in a notebook and you press play. Now, when you first start Python, it actually has a little message here that prints out, and it tells you which version you're running. And I haven't updated Python in a while. When I run that, I get 3.9.12. And it just prints out right underneath here. Python 3.9.12. Now, the kernel is going to be running one of those, some version of Python. If you're using, I think, Colab or other notebooks, there should be a place where it specifies which kernel you're using, and you can switch kernels. I've seen that before, but you don't have to worry about that. That's more complexity than you have to handle. Any questions, though?
What are your thoughts about Jupyter Notebook?
I hate them, but they're a great teaching tool. So everything I do, I store in files written in Emacs and run on command lines. Or my favorite way to run things is AWS Chalice. So the AWS command line interface, CLI, is a way for you to, from the command line, interact with your AWS account. Not that you have one, but you could get one, every one of you. It's not free though. But the idea is that you get a key and a secret key from Amazon, and then you can deploy things from your command line. And Chalice is amazing because it incorporates several services at once. And out of the box, it'll easily configure something called API Gateway and Lambda for you. And what it allows you to do is write a simple Python program that can receive input in JSON and return output in JSON and deploy it to a serverless endpoint. Serverless just means it's a function that Amazon runs for you, and you don't have to worry about it. You don't have to think, okay, what version of Linux is it running on? No. What version of this, what version of that? It's just running. Just trust us, it's running. And since it's serverless, Amazon will spin up more listeners for you as needed. And you can set limits if you want, but potentially you can do it unlimited. Where if you have no users today of your function, it doesn't cost you any money at all. But if tomorrow 1 billion people watch your Super Bowl ad and want to use your function tomorrow, it will spin up as many as are needed. That's my favorite new tool. It's not new, but it's very useful. All right, these are some of the sentiments that go into Python. Why Python was made in the first place. We want our code to look beautiful rather than ugly. Now, that's all subjective, but elegant code is beautiful. Python should be elegant. And Python has made itself easy to write elegant code in. Explicit is better than implicit. So if you're doing something, make it easy to understand what you're doing. So another programmer could see your code and get the idea behind what you've done. In C and C++, I've seen very difficult code. Code that you can only decipher what they've done once you write some other program or do some other analysis, say, okay, this list is pointing to that place in memory, and some other program is pointing to the same place in memory and overriding in weird ways. No, in Python, you don't want any of that. Okay, simple, better than complex. Makes sense. But what does that fourth line even mean? That's a good way to put it, yeah. So a complex system, for instance, is a system where you have things that interact, and every interaction is easily understood. But out of a lot of interactions, sometimes patterns can emerge. Well, complex is okay, but complicated is more like tons and tons of details, more than you could ever remember. Another way to think about this is that when you look at a page of Python, you should be able to understand what's going on and not have to, scan down 10 pages to understand what you're looking at. Readable is more important than being efficient. This one's kind of my opinion. The reason I use Python is not to get the code that runs the fastest. If I want that, I'll probably use C. I want code that's easy for me to write and other people to write and read. I want code that maybe it runs a little slower, but it's easier to update. It's easier to try out new things. These days, compute is so fast, so cheap. The real rate limiting factor is your time and your friends' time, your coworkers. That's the real rate limiting factor. And Python makes that faster. Okay, who can guess why I have this slide here? One of the first things I heard about Python was that it has duck typing. What the heck is duck typing? Anyone know what strongly typed languages are? In a strongly typed computer language, if you define a function that takes in an integer and a float and a string in that order, but then you send in 2 floats and a string, it will complain. So let's say you had in some other language, some func, and I need more space. Let's call this not Python. I'll still write it like Python, but pretend it's not Python. Okay. Yeah. Okay. So let's say we had some function like this, and then you call it in a strongly typed language, it will complain immediately because 1.0 is a floating point, not an integer. But in Python, unless you explicitly say so, you don't have to declare these. You can just do this. Now, remember I said that Python is very flexible and you can do whatever paradigm you want in Python. You have the choice. You could define each of these and make it into a strongly typed language where the type of each variable needs to be closely adhered to. But I prefer normal mode, as it were, where it's just taking in three things. I happen to be passing a 1, 2, two floats and a string. Then when I do things with those, maybe I'm doing x plus y. Well, in strongly typed languages, you'd have to convert the int to a float before you can add it to a float, or vice versa. Because the addition function is different for each. But in Python, hey, you can add them up. It's fine. No big deal. Now, adding a number in a string, that it will throw an error. But for the most part, if it quacks like a duck, it's a duck. Who cares? If it seems to add together, or if you're passing an object, let's say. So now it is Python. Let's say that we're going to make this object that's getting passed in, we're going to make it fly. And let's say separately, we define two classes. And each of them has a method to fly. I pass in a bird, it works fine, no problem. I pass in a plane, it works fine, no problem. If it quacks like a duck, duck. Duck typing. All right, these are some very useful packages. Now, how many of you have gone to the shared folder where we have these slides? Okay, you all should do that just so you make sure you can refer to these slides later. Okay, these are some of the more useful packages you will come upon. This is actually also listed in your slide. NumPy and SciPy. I actually use all of SciPy, not just the stats. NumPy and SciPy are both super useful. Question?
Yeah, where do we find this slide?
On the syllabus, there should be a link. If there's not, ping me or the TA. There is. Matplotlib is all about plotting, of course. All of the machine learning you will need this course is in sklearn, scikit-learn. If you want to be fancy, you're welcome to use PyTorch, TensorFlow, JAX, something else. And Seaborn, we've already started using that. And pandas, I told you guys how much I don't like pandas. You're welcome to use them, but I would suggest you use polars instead of pandas, but you can use it the same way. All right. Who knows the difference between the first two things? Who remembers? All right. That's how you define a tuple and how you define a list. They both look like the same kind of thing. Why have those two things?
You can't change the values of
That's right. Once you define a tuple, it's permanent. Now, obviously, you can get rid of it and make a new one, but why would we even have that? I mean, who likes to have a list that you can't change? Why do that in Python?
it's like a value of constants that don't need to change.
Yeah, but what if you change your mind later and want to change it? Why even have this as a one of the base formats, one of the fundamental memory types? Memory is the key, it has to do with memory. And it has to do with the way we had to program before nice, easy languages came along. So in the old days of C, we always had to do mallocs, memory allocations. And if you want, yeah,
It's just sort of similar to how we branches references.
that was a Java decision, and I can't remember what went into that.
I just don't have the manually moving data. Changing times you first something can change something, all of the points of changes elements.
Yeah, it's not an easy thing to get right. Java was written so that you would have to run it the same everywhere. And you wouldn't think about the low level things like how much memory do I have allocated for this or that. Now in C, you would write the way that you were aware of how much memory you have. And when you store a list of things, you need to allocate memory for that. And since you're doing that explicitly, it's only happening once. And it's only happening there. And if you want to make that list longer than the memory you allocated for it, you have to allocate more memory. And that takes time. In Python, what happens instead is it's going to do it for you. And if you have a list of things that gets too long for the memory that it automatically allocated for you, then it will automatically allocate more memory. And maybe you can move everything to this area of your RAM, but it does it all for you. Now it can do it more efficiently and fast if it knows you're never going to change the list. If you're never going to change the list, then the underlying somersault and backbending that it's doing for you are more efficient. That's why they even have this. You don't notice any difference in speed though until they're really long. So I don't really worry about it much. In mathematics, there's something called a set. What is it?
So a set would be sort of a list of values, but the order doesn't matter at all. It's like a domain.
Mm-hmm. So you can think of it as just a bag of things. Is this a set of numbers? No. Correct, it's not. Why is it not? Because it has two sevens. In a set, either something's in the set or it's not. It's never in the set twice. So keep that idea in your head. Does anybody know what a dict is?
hash table you have hash addresses for things. Everything has, it's like a dictionary, like everything has,
Entry and definition, right? What were you gonna say back there?
Oh, it's like, yeah, dictionary for something that's something else like that would be the list of listers. It's pretty easy to access because you have the actual.
Yeah, and what some people call it is an associative array. And the way you define it in Python, you would start off, if you want to create an empty dict, you do that. Or another dict, you could define it with a couple values. This dict has two entries. And I can use integers or strings for the entries.
It's sort of like a,
Yes, very similar, same thing.
it's the difference between that one and the actual keyword. Inside the, I know that's another way to see it.
Oh, you mean the two initializations I did?
Yeah, there's that one, and then there's E equals thick with the parentheses.
Oh, okay, so that's, there's often more than one way to do something. In Python, I would suggest one of these two ways. If you're going to, create an object with the dict, what's going on there is, come up with the same thing in the end. But in object-oriented programming, you typically think of an object as having a constructor. And the constructor is just a function you call that spits out the object. This skips that. It just goes right to defining it. It's almost like this bracket here, curly brace, is acting as a constructor. And it's saying, okay, Python will see this and understand, okay, you want to make a dict and you want to have two things in it for now. And this equal sign is going to accept what's actually behind the scenes is the memory location of that thing. And you just store it in this variable. But this is doing all that work for you. Much easier way to do it in my mind. So here we have strings as our keys and integers as the values. Now I just said it 20 seconds ago, but what else could go as a key? What? Yes, an integer. An integer or a string, that's it. Nothing else. You can't have floats, and you can't have, custom objects of other kinds. You can't have a list as a key. But all of those things could be values. Instead of 5, you could have 5, 6, 7, 8. For apples, maybe you have 4 kinds of apples now instead of 1 kind of apple. So you make this instead. And you have, 5 of one type of apple, 6 of another. You don't have to change this. What's so nice about these is no matter whether you start like this or start with integers, you can add in some keys that are integers later. And the values can be whatever you want to point it to, because really it's just pointing to a place in memory. And the place in memory here is where it's storing this list or this integer. The other thing I really like about these is they are really fast at finding that place in memory. It's a hash. And that actually goes back to hashing functions. Who here has heard of hashing functions? So in a hashing function, typically you have maybe an infinite set of possible inputs, right? I mean, how many integers are there, right? And you map it to a finite set of things. Now, when you create this dict, even though it has nothing in it, behind the scenes for you, Python has allocated some section of memory. And maybe these represent, bytes. But in this memory, it's saying that this whole section of your RAM is now allocated to a dict, and the memory location of the thing that's managing this is stored here. Then automatically for you again, it will take something like apples, and it runs a function on that maps to somewhere inside this memory zone. And it will map oranges somewhere else. And then the thing that's actually stored in here is not the 5, 6, 7, 8. The thing that's actually stored in there is some other memory location where the 5, 6, 7, 8 is stored. So you can think about it as an index of links, right? So it uses a deterministic function to go from this string or int, map to a location, you can do that super fast. And then that location points you to another location, and you can do that super fast. And we call that O1. Big O just stands for an order of complexity in computing. Things that can take multiple more steps. There's a lot of math behind it. You can do a deep dive on that on YouTube. But this is the fastest anything possibly could be for retrieving information. Super nice. Now, if again, you start to get conflicts, like let's say apples and oranges actually landed on top of each other, because that does happen sometimes, that's called a collision. Python tries to look out for that for you, and it will merely double the size of the memory allocated, and that won't happen for a while. There's a lot of the behind the scenes stuff that hopefully you're interested in, and it's good to know, but you don't have to worry about it. And that is part of why we use Python, because you don't have to worry about it. When you're using Python on a command line instead of in a notebook, you have to think about exactly which version of Python you're running. You usually start with Python 3, because that will call the right version of Python. And we like to make a virtual environment where you're going to do your pip installs. Now, in the notebook, we did that exclamation point pip install, remember that? That loads whatever thing you're loading for that notebook, for that session. And again, as you see, it goes away after a few hours. You have to do it again. Well, when you're using a command line, it doesn't go away. What I typically do are these steps. The first one, the -M, means use this module. And the module is called virtual environment, VENV. It's just something that comes with Python. And give it a name. Let's say we call it whatever. And that whatever could be a full path to somewhere else. I typically keep my environments somewhere separate from the actual code I'm running. Some parallel or higher folder. Then you run source to that new virtual environment you created, and you're calling the activate function under bin. This gets created automatically when you run that first line, but running the second line activates it. Now you're in that quote unquote environment, which means you can pip install whatever you want, and kind of stays in that environment, like Vegas. What happens in Vegas stays in Vegas, right? What happens in that environment is going to be only in that environment, and you can install anything and it's not going to mess up other stuff. So let's say we activate that, and then we install some module. Then when we start Python, and again, by running Python, you'll get this kind of prompt. Then you can import it, but you probably can't import it until you've installed it. Questions? And I think that's a good place to stop. Thank you, everybody.